Let's do some problems with plotting points and graphical representations of functions. So I didn't write the problem here, but what they ask us to do here is figure out the coordinates of each of these points. So let's just do that. So first, we have this point A right there. So I'll just write A is at the coordinate. So we write the x-coordinate first. So its x-coordinate is how far to the left or the right it is of the origin. And it is 1, 2, 3, 4, 5, 6 to the left. Or it is -6 of the origin. Or it's at the coordinate -6. So -6, that's right there. And then its y-coordinate, which is how high it is, that is right there. That's 4. -6, 4. Let's do B. B right there. B is at the coordinate. Let's see, its x-coordinate, just drop down there, is 7. And its y-coordinate, how high it is 6. All right, let's do C. C, the x-coordinate, you can read that. It's -8. It's 8 to the left of the origin. -8. And its y-coordinate, it's 2 below the origin. So its y-coordinate right there is -2. All right, this is, I think, not too painful. Part D, or coordinate D, or point D. Point D, its y-coordinate, it's at 4. 4. And then its x-coordinate is at 4. And then its y-coordinate, how far down it is, or in this vertical axis, this looks like -7. -7. And then finally, we are on E. Picking a nice color for E. E right there. Its x-coordinate is 5. It's right on the x-axis at x is equal to 5. And its y-coordinate, well, it isn't above or below the origin or the x-axis. So its y-coordinate is 0. You could draw a line and go straight there to 0. So there we go. We've figured out all of those coordinates. Now, this problem 5 here, let me scroll over a little bit. They say determine whether each relation is a function. So here, the trick is to realize that a relation is not a function if they define two values for a given x. Let me give an example here. So if I wrote that f of x is equal to 5 if x is equal to 1, or it's equal to 6 if x is equal to 1. This makes no sense. This makes no sense. Why doesn't it make any sense? Because if I put a 1 in there, I don't know what I'm going to produce. Am I going to produce a 5? Am I going to produce a 6? This is a badly structured function. This is not a function. So if there's any situation for the same input value, they define two different output values, we're not going to have a function. So let's see if they do that here. So in this first part, part A, they say if you could imagine if x is 1, then y is 7. If x is 2, y is 7 as well. That is OK. You can have two x values getting the same y value. For example, that would be like saying f of x is equal to 7 if x is equal to 1 or 2. This is completely fine. For two different x values, you can get the same output value. But you can't have two different x values giving the same, you can't have the same x value producing two different outputs. Because then you don't know, hey, if you put f of 1, you don't know what f of 1 is. F of 1 is it a 5? Is it a 6? You don't know. Here you know what f of 1 is. It's 7. Here you know what f of 2 is. It's 7. So far, so good. So when you have 2, you have a 7. When your input is 3, you get an 8. When your input is 4, you get an 8. So for example, our function definition, so it's 8 if x is equal to 3 or 4. And then 5, and then our function is equal to 9 if x is equal to 5. So part A, this is our function definition right here for part A, which is a completely legitimate function definition. You give me any value 1, 2, 3, 4, or 5, which would be the domain in this situation, and I will tell you what the value of that function is at any of those points. And the range would be 7, 8, or 9. So part A is definitely a function. Now part B, let's see, if x is 1, y is 1. But then they say if x is 1, y is negative 1. Well, that makes no sense. They're doing this right here. They're trying to make a function where they say this function is going to be equal to 1 if x is equal to 1. But then it's going to be equal to negative 1 if x is equal to 1. So if I were to take f of 1, I don't know what it's going to be. Is it 1 or negative 1? I don't know. Do I take this one or do I take that one? So this is not a function. So part B is not a function. That relation is not a function. All right. Let's do a couple of more. Problem 6. Write the function rule for each graph. So we have this little V-looking thing. So we could write it a couple of ways. Let's call it f of x. You could call it g of x or h of x. But if you haven't used your f yet, people tend to use f of x. So this is x. So let's see. It looks like it's one line when x is greater than 0, and another line when x is less than 0. So it's one thing when x is, let's say, greater than or equal to 0, and another thing when x is less than 0. And I'm going to merge the two in a second. So what does the line look like here? When x is 0, y is 0. When x is 2, y is 1. When x is 4, y is 2. It looks like no matter what x is, y is going to be 1/2 of that, right? When x is 6, y is 3. So it's equal to 1/2 x when x is greater than 0. And then when x is less than 0, when x is negative 2, y is 1. When x is negative 4, y is 2. So here it looks like it's the negative 1/2 of it, right? Negative 1/2 times negative 4 is positive 2. So it's negative 1/2 times x when x is less than 0. So this is a completely legitimate answer. But if we wanted to make it a little bit simpler or clean it up a little bit, we could write this function definition as f of x being equal to, instead of dividing it between greater than or less than 0, let's just take the absolute value of x and then multiply that times 1/2. Right? Because here, that obviously works for positive values, because the absolute value of x will be equal to x. But then for negative values, the absolute value of x is equal to negative x. So you take negative 2 here. Negative 2, take the absolute value, you get 2 times 1/2 is 1. So either of these would be legitimate function definitions. Problem 10. Use the vertical line test. Let me switch colors for this one. Use the vertical line test to determine whether each relation is a function. Now, the vertical line test is just a visual way of doing exactly what we did in this problem over here. Something is only a function if for a given x value, you only have one y value. So for example, when they say a vertical line, that means at any point, I should be able to draw a vertical line on this function and only intersect it once, right? Because a vertical line says, look, when x is equal to 3, there's only one value that I can get on our function, right? That's what I'm doing with the vertical line. When x is equal to 0, there's only one point on the function that is mapped from x is equal to 0. So this one right here is a function. Any vertical line you draw will only intersect the function once. This one, very clearly, you draw any vertical line. You draw any vertical line here, and you're going to intersect the graph twice. So this is saying, this vertical line that I just drew, this is essentially saying f of 2 could be this point over here. This looks like, I don't know, maybe it's equal to, it could be equal to 1.9, or it could be, what is this, negative 1.9. This is not a proper function definition. I don't know whether f of 2 is this value or that value. I don't know whether f of 0 is that value or that value. And you could keep going across the whole number line. You don't know whether f of 5 is this value or this value. So this is not a function. This relation is not a function. Not a function. And it's the same logic as we did before, but we're saying the vertical line. You can draw a vertical line, and you can intersect the relation or the graph twice. So it's not a function.